All right, so I'll record the second of two videos that describes a transformational argument why one triangle is congruent to another. So in this particular case, we have lines B, W, and GN crossing at I. We are supposing that BI is congruent to WI, and that angle GBI is congruent to angle NWI. We are looking to give a transformational argument as to why triangle big is congruent to triangle win. That is to say, we want an isometry that maps big onto win, and then we justify why the isometry is correct. Now, if we were doing this proof a month or so ago, we would take a look at this and say, oh, look, those are vertical angles, and therefore angle, side angle, and we're done. But that's not what we're shooting for here. We're shooting for a transformation-based proof. And so we've got to find an isometry that puts big on top of win. That's the goal. And so I'm going to set this up there. I'm not going to write all the setup. Again, that is for you to do. Assume lines GN and BW cross at I, such that BI is congruent to WI and angle GBI is congruent to angle NWI. We will show by transformations the triangle big is congruent to triangle win. That's the setup. For us, we're going to consider the only transformation that I can imagine that does the job, and that's a half turn about I of triangle big. And we're going to denote this by triangle B prime, I prime, G prime. We will show that B prime is W, I prime is I, and G prime is N. And some of these arguments are easier than others. For example, the I prime equals I argument is pretty straightforward, because I is the center of the half turn. I prime is I. We're a third of the way there. So then what happens? Well, on a half turn, opposite rays end up on opposite rays. So this point B ends up on ray IW. It ends up somewhere on ray IW. We'll say that because IB and IW are opposite rays. B prime is on IW. But where? Where on IW is it? Well, we know that the distance IB is the same as the distance IW, and so by the ruler postulate, which is still an axiom, because IB is IB prime is IW, B prime is W. So now we're 2/3 of the way there. We have placed I prime at I, and we have replaced B prime, we have placed B prime at W. Well, then what happens? Well, then angle GBI has an image over here. G prime is on a ray that makes the same angle that NWI is. So, because angle GBI is congruent to angle G prime WI. Just to be clear here, G prime B prime I prime is the same as G prime WI. So because those angles are congruent, G prime is on ray WB, right? It's not true. It's WN. Oh, sorry. It's on ray WN. That's what I get for not taking a look at the picture carefully. G prime is somewhere on this ray. And it has to be because protractor postulate part 3 says there's only one ray that makes that angle. There's only one ray in this half plane that makes this angle, so G prime is somewhere on the purple ray. But because H is a half turn, and let's get the names right, ray IG and ray IN are opposite rays, G prime is on ray IN. Now, what do we do with that information? G prime has to be on ray WN, and G prime has to be on ray IN. So G prime has to be the only point that's on both of those rays. Therefore, G prime is N. It has to be on ray WN. It has to be on ray IN. There's only one point that's on both of those rays. That point is N, so G prime is N. We have an isometry under which B prime equals W, I prime is I, and G prime is N, and thus triangle big is congruent to triangle win as needed. In all of these transformation-based proofs, we start with an isometry, and then we show that the points we want end up where we need them to be by properties of transformations. I hope these two are helpful to you as you go into discussion 19. There are lots of opportunities to practice in discussion 19.